Let's analyze the car following process. One vehicle follows another in the same lane. It can be interpreted in multiple ways. Here we are going to compare two. The first approach is known as traffic flow theory. It takes a motionless picture of the situation and states the following. The road space occupied by a vehicle depends on 1. The length of the car. 2. The separation between the vehicles. The second way of interpreting car following has been termed wave driving. It takes a motion video of the situation and states the following. The road space occupied by a vehicle depends on 1. The length of the car. 2. Safety distance. 3. The anti-jam zone. 4. The unused or remaining space. What's the right approach? Let's start with the official approach, traffic flow theory. Let's go back to the two vehicles we saw first. As we have taken a picture, we find that they keep 1. A speed v. 2. A separation between them. If we compare it to the chart below, it seems that everything is correct, right? If we apply this scheme sequentially, we create a platoon of vehicles, and you get the fundamental equation of traffic for this type of engineering. The flow of vehicles by a lane is the product of the average spatial velocity by the average density. Very important, this is a statistical equation. It refers to average values, which can be applied to everything that goes through a section. Fluids, gases, conveyor belts, and traffic, of course. When doing a macroscopic statistical study, you get a graph parabola, with two areas well apart. 1. A zone above the maximum intensity, represented by the continuous line, that is adjustable by least squares. It's the area of self-paced free flow, or fluid traffic. 2. A lower zone, shown by the discontinuous line, that is a place of uncertainty, mathematically unadjustable. This is the area of traffic jams, forced pace traffic. Look at both areas, which one is bigger? Why can't vehicles circulate below 90 miles an hour in a fluid way? We're going to understand it with wave driving. We flew to the vehicles we saw at the beginning. Wave driving doesn't freeze a picture, it takes a piece of video instead. The first vehicle is varying its speed, but the second one, for convenience in our explanation, keeps a constant speed, of equal value as the average speed of the first vehicle. See the variables concerning the follower vehicle. 1. Its velocity, which we have said is constant. 2. The separation, we will come back to it later. 3. A variable space, that defines the anti-jam zone, necessary to be able to maintain a constant speed. 4. The wasted space, because even if you keep the same average of the leader, you can do it more or less near of the preceding vehicle. Under the wave driving approach, if we apply this scheme sequentially, we create a platoon of vehicles, and you get the fundamental equation of traffic for this type of engineering. The motion wave of the last vehicle is the wave of the movement of the first vehicle plus the management of the space made by each of the following drivers. It is very important to note that it is not a fundamental statistical equation, but an exact one, without loss of variables when taking average values. Why do waves appear in the equation? Because it refers to periodic movements or oscillations, and so the best mathematical demonstration of wave driving is not done from a cinematic point of view, but from an undulatory one, although a closer examination of such fundamentals are out of the scope of this video. If we analyze the intensity-velocity graph, we see clear differences. 1. The stable traffic zone is much greater than the forced traffic one. 2. However, a price is paid for it, instantaneous capacity decreases. 3. The maximum intensity speed no longer determines the boundary between the two zones. 4. The fluid traffic velocity is below that of maximum intensity. What's the right one? If we take WaveDriving with its 4 variables. 1. Speed. 2. Safety distance. 3. Anti-jamming zone. 4. Unused space. And we make the variable 3 worth 0. And that the variable 4 is also worth 0. Then it turns out that what we get is nothing more than the old traffic flow theory. In other words, the third and the fourth variables define the level of stability of the platoon and the correct use of space. This is why drivers who only drive with safety speed and distance produce traffic jams. Compare the two types of drivers. The first type is the driver who has been on our roads for 100 years. He or she has never received training on traffic jams, and so the consequences are traffic jams. The second type of driver, WaveDriver, can be a human being with an aid to driving or an autonomous vehicle. It doesn't matter, in the end the equations you have to solve so that there are no jams are the same. It can be helped by a GPS, Waze, it can be an autonomous vehicle, it can be a connected vehicle, or be communicated with the authorities or simply be a driver with anti-jam training. In the famous experiment at the University of Nagoya, the drivers were told to try to keep a constant speed. The tactic was as follows. 1. Many vehicles, high density. 2. To remove vehicles as the whole platoon was fleeing in the objective of a fluid traffic. In short, the jam was eliminated by applying ramp metering. In our experiment at the Polytechnic University of Madrid the approach was different. 1. A stop-and-go robotic vehicle with GPS precision that would cause little blockages systematically. 2. Only a few vehicles, and no more actually needed. We managed to eliminate the jam in just 10 seconds, with a verbal sentence. We don't need more for a driver to start using more than 2 variables. The differences were clear, the ratio between fluid and forced traffic changed dramatically. Let's see it in more detail. We have duplicated the paraboloid graphs, a vertical and a horizontal one. You now must imagine it in your mind. Drivers that just keep safety distance cause the maximum level of traffic instability. Then, as we stabilize the traffic we observe 1. A decrease in the punctual capacity of the road, but an increase of the practical capacity. 2. An increase in the speed range for free traffic. As we see, the famous graph of the intensity of a road is actually nothing more than one of the lines of a family of intensities. Out of the whole family of curves, the one that interests us is the one giving us the greatest value of the practical capacity. It is no good to get high punctual speeds if the price is coming big jams. For all kind of drivers, human, autonomous, guided or remote control, you can obtain the valuation in these factors. 1. Speed efficiency. 2. Space efficiency. 3. Efficiency in individual road safety. 4. Efficiency in collective road safety. 5. Efficiency in consumption, emissions and healthier roads. However, we keep sticking to traffic flow theory. Why don't we train drivers about traffic jam dynamics at the traffic schools? We will now focus in a real case. Spain, the A42 road, near Madrid. All working days, in this same place, at the same time, the same drivers are found. With the same cars, with the same distress, with the same haste, with the same bad fumes. All of them have been educated with the idea of keeping the distance safe. Here you see the results. However, What if we are using wave driving? It is true that we would not be faster than the vehicle that precedes us. But we would consume half of fuel. And we would pollute half of it. In addition, our risk of an accident is much lower. On the other hand, although not seen in the video, we were making the vehicles that followed us not having to stop. We stabilized the flowing traffic behind. Now we're just one. But tomorrow we will be 2 drivers. Then 4, and so until there comes a moment in which we reach the critical mass, that is, that we are enough wave drivers so that at this point phantom traffic jams are no longer produced. We can do it by 1. Training drivers. 2. Generating apps for smartphones. 3. Onboard devices. 4. And applying variable signs. According to traffic flow theory, a traffic jam occurs because some road reached its capacity, more lanes are needed. According to the wave driving approach, that traffic jam occurs because drivers reached their limits to manage available road space. Put simply, more intelligence is needed, but it is available, to be sure. Now, just watch what happens. Why is this traffic jam? This is a phantom traffic jam.
Look at what happens when a vehicle slows down. The colored lines represent the speed of passage of each vehicle. The first vehicle slows down, but never stops. Each driver's safety distance is forced to brake a little more than the previous one. In the end, there is a vehicle that must be stopped. This is the phantom traffic jam. A wave driver starts braking before the vehicle preceding it, but its minimum speed is the same as the vehicle preceding it. The blockage never gets to be generated. In our real case, head-off A. Speed reduction is due to a curve, not a change in the speed limit, but it is the same. The first phase is then a systems analysis. The second phase is to stabilize the traffic, using all the means that we have indicated above. The third phase is to raise the minimum speed as much as possible, but within a stable traffic.